Hello, and today we're going to look at functions and function tables. And we're also going to talk about graphing. First, functions. What is a function? Well, functions are a special relation in which each member of the domain, which is called the x values, is paired with only one member of the range, the y values. So, for instance, in these 4 points, 3, 5, 6, -3, -4, 0, and -7, -1, the domain would be all the x values, 3, 6, -4, and -7. The range would be 5, -3, 0, and -1. Those are just their values. Now, each domain value has only one range value. So if you look at these two tables, this example of 4 points or coordinates is a function. This is not. Look at the two charts. First, the one that is a function. If I write down each x value or each domain in the first column and each y value or range value in the right column, and I put an arrow to where they go, notice how each one on the left only goes to one value on the right. But in the second example, putting all the x values or the domains to the left and all the y values or the ranges to the right, notice that -2 has two separate answers in the right column. That is not good for a function. So, that is not a function on the right. This one is, this one isn't. Basically, this is the way you need to think of it. If all of your x's are different, then you're fine. But if you have two x's that are the same and they have two different y's, it's not a function. Now, there's also a way you can test a function from a graph, and it's called the vertical line test. In the first example, each one of these dots is the graph. Is this a function? Well, if I took a pencil and put it right here over that first point, it would only go through that first point and none of the other ones. And if I slid that pencil across, it would still only hit one point at a time. Therefore, it is a function. Over here, if I start with my pencil to the left and drag it across this graph, notice it hits in multiple spots at the same time. Therefore, it is not a function. Now, how does this help us? What do we have to do? Well, first, let's talk about the function tables. If you have a function table, it has two sides, an input and an output. The input is your x or your domain. The output is the range or the y. You have to find the outputs from a set of inputs or vice versa. Now, the input and output are joined together to make that point consisting of two numbers, x, y, input, output. So let's put it all together and let's look at some problems. First, here's an easy one. Let's say I'm given a function that says y equals x plus 2. Well, I start with my input table. All the x's are on the left. Those are your inputs. If I plug those numbers in, the output is found. So if I put a -2 in for x, -2 plus 2 is going to be 0. So I put a 0 for the y. If I put a -1 in for x, -1 plus 2 is a +1. Put a 0 in. 0 plus 2 is 2. Put a 1 in. 1 plus 2 is 3. Put a 2 in. 2 plus 2 is 4. Now that I have all of my points, I can now graph them. Remember, when you graph these points, you take the x value, and that's your left and right, and then the y value is your up and down. So the first point is -2, 0. So I start here. I go to the left 2, and I go up and down 0, so I put it right there on the line, and I put a dot. The next one is -1, 1. So I go left 1, up 1. Then 0, 2, 1, 3, and then 2, 4. Remember, when I'm graphing these points, I start at the origin, and then I start moving x first, then y. Now, to graph this completely, I then connect the dots with a straight line, and I make sure to put 2 arrows on either end. And there's my function. That is what the graph looks like. Let's try one that's a little bit harder. Let's say you have y equals 3x minus 2. In this situation, go ahead and plug your numbers in. Here are my x values. I'm going to plug them in, and then I'm going to find my y values. So, the first one I plug in is 3, parentheses, negative 2, which means to multiply, and then minus 2. Well, 3 times negative 2 is negative 6. Negative 6 minus 2, they are the same sign, so you add together, keep the sign, negative 8. Next, put in a negative 1, and then a 0, then positive 1, and then positive 2. Again, you could type these into a calculator to make it easier on yourself, but you should get the following answers. If you do not get the following answers, please check on your calculator yourself, but if you don't get them, please ask me for assistance or I can help you through it. Now, go ahead and graph these. There's my trusty graph. I'm going to start with negative 2, negative 8. So left 2, down 8. 1, 2, 3, 4, 5, 6. Notice right here that this value of negative 8 would go off the chart. I am not going to graph negative 2, negative 8. But all I need to have is 3 points in order to make my line. So I'm going to go negative 1, negative 5. 1, 2, 3, 4, 5. I do have a dot there. 0, negative 2, 1, 1, and then 2, 4. So I ended up having enough dots to make my line. No big deal. Put a straight line through with arrows, and you're done. Last one, a little bit harder. This one's messed up because of the negative in front of the x. That's why people would have difficulty with it. Remember, plug the numbers in. So in this case, x is negative 2. Plug it in where the x goes. So it says negative, negative 2. Well, when you have two negatives, it becomes a plus. So this is positive 2 plus 4, which my answer is 6. Go ahead and plug in the rest of the numbers, and these are the answers you should get. Next, let's graph it. So, negative 2, 6, negative 1, 5, 0, 4, 1, 3, 2, 2. And there are my points. Connect them with an arrow on either side, and you're done. Take your time on this lesson. Go back and relook at the examples, and as always, thank you for using Seyer Mathematics.